Welcome back, students. The first new topic for Chapter 7 is Section 1.3 of this notebook, Index Shifting. There are two types of index shifting that appear in our textbook. One is for integrals. Let's increase the font a little bit. And one is for series. Which is more important? The series part. The integral part, it may show up in some of the exercise problems in the back, but I'll try to avoid those kind of problems. So in this video lesson, let's stick to the series part. How do we handle index shifting? The purpose of index shifting is to bring down the power t to the n plus first power into t to the nth power. If we have to begin with t to the n plus second power, again bring it down to t to the nth power. Sometimes bring it up, t to the n minus 1, n minus 2, or n minus 3 power, all the way up to t to the nth power. There can be many different ways, but the purpose is to get t to the nth power, the desired expression over here. How do we do that? One way to handle it is to use a change of variable. This is what you want to change. So take that as another character, say m, and then change the other part accordingly. M is n plus 1, so n is equivalent to m minus 1, isn't it? So this m plus 1 is m, and then you see n is m minus 1, so yeah. Down here, n is beginning from 0, so m is beginning from 1. Looks like I didn't really have to use this part, but please note that this part and that part are equivalent. In any case, after this intermediate part, we can rewrite m back into n, then we get the desired expression. Or you can do this directly. You see, instead of changing n equals to m minus 1 and change the character, go directly. New n is old n minus 1, so this n becomes n minus 1. This n becomes n minus 1. And this n becomes n minus 1. You see, just change all n to n minus 1, as you saw over here. If you do that, you're going to get the final expression. Do they work? Well, let's see. Do they work? They will. What's the first expression? 0 plus 1 to the 0 plus, excuse me, t to the 0 plus first power, isn't it? The next expression is 1 plus 1, t to the 1 plus 1 power. And I plug in n equals to 2 here. 2 plus 1, t to the 2 plus first power, and so on and so forth, isn't it? Plus dot dot dot. But then again, what is this expression here? It's the equivalent of 1 t to the first power. And how about the second expression here? Equivalent to 2t to the second power. And third one is 3t to the third power, and so on. Do you end up with the final expression? Yes, indeed. So you can check those using first several terms as well if you want to. And especially if you have lots of time, then maybe it's a good idea to use multiple ways to check your computation. Anyway, you can use different character in the middle, or you can go directly. In any case, the key is to get the middle part. Yeah, this part. That is the key part. Whether I just use different character for m equals to m minus 1 like that, or just, you see, reuse the same character before, Either way, the key is nu n minus 1 or n minus 1. Let's see. Do you have time for an exercise problem? Okay, let's go. Use the index shifting to express a given series as a power series of x plus 1 to the nth power. Let me expand the font even further. You see this one is given as n plus first power, but I'm going to bring it down to nth power. So the key is to change this one accordingly. How do you do that? Change this one, n plus 1, as new character m and working out. Or another way is to replace this one as n minus 1, eventually get n. Either way it works out. And here are the solutions. First way, change a variable. This n plus 1 is becoming m, and then change n's into m accordingly in all other expressions, and then getting an expression back in. Or you can rewrite n minus 1 plus 1 on this power so that you get n power, and repeat the same thing to all the remaining n expression here. To this expression you put n minus 1. To this expression I put n minus 1, and also this expression I put n minus 1, and then work those out, and then you get the final expression there. Either way it works out. Our textbook out there almost exclusively uses the last method over there, but I've seen many students who do not really feel comfortable with this. But in any case, what choice do you have? You really have to go through those. And if you're unsure about what you did, you can check by putting first several terms and reconstructing the series. No matter what you do, I don't care. In the end, you have to get your series done according to the given power. Excuse me, the power part I wanted to emphasize was only this part. By the way, do you recognize this function? It's a log function.